2.6 rational functions and asymptotes. What we should learn: find the domain of rational functions, find the zeros and horizontal asymptotes of graphs of rational functions, and use real functions to model real-life problems. So rational function is when you put a polynomial over a non-zero polynomial. So like this. So that's a rational function. It's just a function with a polynomial over a polynomial. We call that a rational function. Now, what's the domain of a rational function? Just like anything else. The domain is you set the, well, any other fraction. You set the domain, you set the denominator not equal to 0. So just like when it's 1 over x, right? The domain is just, oh, you get x does not equal 0. So that works for any polynomial function. Now, when you have a graph like 1 over x, it looks like this. This will show you. And two things pop up. So when you graph 1 over x, hopefully you notice that there is a vertical line right here. Which is like an imaginary line that you cannot cross. That's called a vertical asymptote. And it's a line you cannot cross. But there's also a horizontal asymptote right here. That's actually treated very differently. You can cross it. You don't always do. A lot of times you don't cross a horizontal asymptote, but you can. What the horizontal asymptote does is it tells you what happens at the end points. That's all horizontal asymptote does. It lets you know what happens at the end points. Happening at the edges, the horizontal edges. So what happens at infinity and negative infinity. That's what horizontal asymptote tells you. So you could cross it. You don't cross it all the time. Most of the time you don't cross it. But what it does do, it tells you what happens at the endpoints. So like here, right? What happens if you go infinity or negative infinity. So that's what horizontal asymptote does. Lets you know what's happening at the endpoints. Vertical asymptote lets you know what values you cannot cross. See, like here, right? There's a horizontal asymptote at 2. If you look at as it keeps on going, it's going to get closer and closer to 2, both directions. But they cannot cross the vertical one at negative 1. Over here, there's no vertical asymptote. But there's a horizontal one at 0. If you look as you go both edges, as you get close to 0, it's getting close to it. This one has a vertical asymptote at 1. So you look, notice nothing crosses it. Horizontal 0 again. As you get close to 0, both sides equals 0. So how do we find horizontal vertical asymptotes? So I generally find horizontal asymptote first, and we do that based on the powers. If the top power, the numerator power, is greater than the bottom power, there is none. No horizontal asymptote. Now there's a special case where the power is bigger by 1. We'll get to that, but in general, if the top power is bigger than the bottom power, there's no horizontal asymptote. For example, if I give you y equals x squared plus 1 over x minus 3, the top power is bigger than the bottom power, there's no horizontal asymptote. There's actually a special case, sign asymptote there, but we'll talk about that later. Okay, what happens if the bottom power is bigger than the top? The bottom is bigger than the top, then you have one at y equals 0. So for example, if I flip that, the bottom power is bigger now, so we have an asymptote at y equals 0. That'll be a horizontal asymptote. And if they're the same, bottom equals top, in that case you look at the ratio of coefficients. So if I give you, let's say 2x minus 1 over 5x plus 3. The powers here are the same, so we look at the ratio. So my horizontal will be at y equals 2/5. So that's how I found horizontal asymptote. I think it's easy besides knowing the process. Like the math itself is easy. You don't have to like solve anything. It's just, oh, top's bigger than bottom? None. Bottom's bigger than top? 0. They're the same as the ratio. You just got, the hard part is remembering all that. How do you find the vertical asymptote? Same way you find the domain. Vertical asymptote, you just set the denominator equal to 0. Domain is not equal to 0, but denominator equal to 0. Because you're trying to figure out where you could not be. That's all it is. So if you want to find the vertical asymptote, set the denominator equal to 0. That's it. So let's do an example. Find all the asymptotes of each function. So for a, I always find the horizontal one first, and we'll find the vertical one. So the horizontal asymptote here, the bottom power is bigger than the top. So y equals 0. Done. The vertical asymptote, we're going to set the bottom equal to 0. So I'm going to get 3x squared plus 1 equals 0. Solve it a little bit. Divide by 3. So x squared equals negative 1/3. You square root it, and then you're going to get an imaginary number. So that means you have no vertical asymptote. Right? If you get an imaginary number, that means there's nothing you can plug in that's going to make this bad. So if you ever get an imaginary number trying to solve, that means no vertical asymptote. So this one has horizontal one at 0, but has no vertical asymptote. The next one, B. So first thing, horizontal asymptote, always do that first. Then we're going to do vertical. So horizontal, they match. So we're going to take the ratio. The ratio here is 2 over 1. Right? The coefficient of the top one is 2, coefficient of the bottom one is 1. So this y equals 2. There's my horizontal. Vertical, we're going to set the bottom equal to 0. So x squared minus 1 equals 0. X squared equals 1. Square root it. X equals plus and minus 1. We actually have two vertical asymptotes. X equals 1 and x equals negative 1. So here we have 2 vertical and 1 horizontal. So now we have vertical and horizontal asymptotes. Next, we could talk about holes in the graph. Sometimes you have a graph where it has a hole in it. It's kind of like this. Where do you get holes from? This is from cancellations. So how do you find the hole in the graph? You find a cancellation. So you have to factor and cancel. So let's do a quick example. Let's say I gave you y equals x plus 3 times x minus 2 over x minus 2. It's like an easy example. So these, since they're factored, I could cancel these out. So again, they're both factored. There's an implied parentheses. So these would cancel out. That would be my hole. My hole would be at x minus 2 equals 0. So you get x equals 2. If you want to find the y value, just plug it back into the equation. So we get an equation that's y plus 3. I'm going to have a hole at x equals 2, but if you want to find the y value, just, y equals x plus 3 is my equation, right? That's what's left over. Look at right when everything else canceled out. That's what's left over. So if you want to find the hole in the graph, you know what happens at x equals 2, plug into the remaining equation, and I get y equals 5. So my hole is at 2 and 5 is my hole. How do you graph it? Well, you graph y equals x plus 3, kind of like this actually, right? Y equals x plus 3, and then put a hole at 2, 5. So that actually works out perfectly. So those are the 3 types of things that could affect your graph. We have a hole. Anytime there's a cancellation, you got to factor it out to find it. And we have horizontal and vertical asymptotes. Remember, horizontal is the powers, vertical is the denominator equals 0. So when we graph something, we're going to find all that stuff. That's the first thing you do. So like here, example, find all the asymptotes and holes in the graph. So the first thing, the way I do this is horizontal asymptote first, because that's the easiest, just the powers. Next, you want to find the holes in the graph. Very important. Holes are next, and then vertical asymptotes last. Where is the denominator equal to 0? Why are holes next? Because factor. The reason holes are next because you can't be a hole and a vertical asymptote. Like here, like the one we did up there, right? Oh, how do you find the vertical asymptote? Set the bottom equal to 0. But a hole comes first, so you got to cancel them out. Now there's no denominator, so there's no vertical asymptote here, right? So holes come before vertical asymptotes. That's the way it goes. So for this one, let's find the horizontal asymptote first. It's just a power, and looks like their powers are the same. So I'm just going to do y equals 1. Right? We'll have a coefficient of 1, 1 over 1, 1. Done. Now we got to do the holes. So I got to factor this. Negative 2 over 1. So that's going to be 2 and negative 1. So I'm going to do x minus 1, x plus 2. You got to be pretty fast at factoring. Make this fast. On the bottom, negative 6 and negative 1. So that's going to be negative 3 and 2. X minus 3, x plus 2. Now notice the x plus 2 will cancel out here. So there's our hole. So hold at x plus 2 equals 0. So x equals negative 2 is where our hole is at. Now if we want to find the y value, we got to with the remaining function. I'm going to do that anyway. Let's rewrite the remaining function. What do we have left over? Y equals x minus 1 over minus 3. So that's the remaining function. And then, look, by the way, look at it. Horizontal asymptote has not changed. Still y equals 1. Now our vertical asymptote, right? That x plus 2 cancel out. It's not part of our vertical. Our vertical is the remaining function. So our vertical asymptote is take the bottom, set equal to 0. So I get x equals 3 is my vertical asymptote. And if I want the point for the whole, like the complete point, I could plug it into this guy. So it would be y equals negative 2 minus 1 over negative 2 minus 3. You get negative 3 over negative 5, which is 3/5. So if you actually want the whole point of the whole, it's going to be negative 2 and 3/5. That's where the whole is at. So that's horizontal, that's the whole, and that's the vertical. Okay, so next one, find the functions domain, vertical asymptote, and horizontal asymptote. So we have this one. So we're just gonna do this real quick. The domain I'm gonna do last, because I gotta find the horizontal first. So let's find the horizontal asymptote first. Look at the powers, they're the same. So take the ratio. Y equals 3 over negative 2. Or just y equals negative 3 over 2. There's my horizontal asymptote. The vertical asymptote. Now again, vertical asymptote and the domain are essentially the same thing. Whatever the vertical asymptote is, the domain is just that, but not that basically. The way we find the vertical asymptote, so the denominator equal to 0. So we're going to go 0 equals 2x cubed plus 18, negative 2x cubed, sorry. And then we're just going to solve. I'm going to add the 2x cubed to both sides. So I get 2x cubed equals 16 divided by 2. X cubed equals 8. Take the cube root of it. X equals 2. Not plus or minus because it's the cube root, so it's just 2. That's my vertical asymptote. What's my domain? X cannot equal 2. If you want to put that in like a fancy notation, well, you can't be 2. You can be everything else. So if you want that in like an interval notation, it would be negative infinity to 2 union 2 to infinity. That's the same thing as saying x cannot equal 2, right? You can be everything but 2. So that this is totally fine. There you go. So let's do an application problem with this. A utility company burns coal to generate electricity. The cost in dollars of removing P% of smokestack pollution is given by this right here. So this is a cost function for P's between 0 and 100. Use a graphing utility to graph its function. You will remember the state legislature that is considering a law that requires the utility company to remove 90% of pollutants from their smokestack emissions. The current law requires 85% removal. How much additional cost would the utility company incur at the result of the new law? Well, we could graph it. We could find the horizontal vertical asymptote, right? Vertical asymptote at the bottom equal to 0. It would be P equals 100. Horizontal, they're the same, so it's negative 800. But the question is just how much more will the cost incur? So if P is this percentage, we're just going to plug in P at 90. And then we're going to plug in P at 85 and then see what the difference is. So what's the cost when it's 90? So I'm going to get that over 10. Over here, 9 times 8 is 72. How many zeros do we have? We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then one of these zeros cancels out. And we get 7200000. So $72,100,000. That's how much it costs. That's what the proposed hike would be. The current law is 85. So the current law would just be this for 85 over 100 minus 85. So over 15. Let me use a calculator. It's going to be 680,000 divided by 15. I'm going to get 45,333.33. So that's the old law. We want to figure out what's the difference. Let's subtract these two. 72,100,000 minus current answer. When you get about 674. Oops. So that minus that 674,666.67. So a whole lot of money the new law would cost. Good. Don't pollute our world. Anyway, that's the lesson.